In this video lecture, I provide the details to the solution involving a previous video lecture. In that lecture, we discussed the rotational dynamics associated with this system, which consists of a tabletop that's frictionless. On the tabletop is a block of mass uppercase M pulled to the right by a string that passes over a pulley. At the end of the string is another mass, a hanging mass that is moving downward. In the previous lecture, I applied Newton's second law in linear form to the block on the tabletop, obtaining that equation. Likewise, applied the linear form of Newton's second law to the hanging block, obtained that equation. And then finally, I applied the rotational form of Newton's second law to the pulley, tau equals I alpha, and obtained this expression. You will need to review the previous lecture to recall or understand where these three boxed equations came from. My intent here is to just do the algebra for you to solve for the acceleration A. So let's get to that. What I will do is substitute into this third equation the two different expressions for T2 and T1. Let's first rewrite that equation for T2. We have that T2 equals mg minus ma. I'll now substitute this expression for T2 into that location and substitute into this location that expression for T1. And so we have R times mg minus ma minus R times uppercase M A, and that equals I times parentheses A over R. We need to solve this equation for A. I will do that by multiplying each term by, I will do that by dividing each of the three terms by R. And so this becomes mg minus ma minus uppercase ma equals parentheses I divided by R squared. Times A. I'll take the second and third negative terms here and put them on the right side, making them both positive, leaving behind the mg. Almost done now. Right side, I'll factor out the A, lowercase m, uppercase M, plus I over R squared, all times A. The final result is that A, the acceleration, in the denominator lowercase m plus uppercase M plus the ratio I over R squared, all of that downstairs divided into mg. Final result then for the acceleration of the block on the tabletop is in the cloud. I hope this helps you better understand what went on earlier.